In 1901, a Greek sponge diver pulled something out of the ocean near the island of Antikythera. It looked like a lump of corroded bronze, but when scientists finally cracked it open, they found gears, precise, interlocking, astronomical gears, buried in a shipwreck from 65 BC. A machine so sophisticated that nothing like it would be built again for another 1400 years. And here's the part that no one can explain. We still don't fully understand how they made it. This isn't one story. This is a pattern. All across the ancient world, civilizations left behind objects and structures so advanced, so impossibly precise, that even today, with all our technology, our best engineers stand in front of them and say, "We don't know how this was done." These are the ancient technologies that modern science still cannot explain. Let's start with that bronze machine from the bottom of the sea, the Antikythera Mechanism, discovered in 1901, but not fully decoded until the 2000s, is a handheld analog computer from ancient Greece, built somewhere between 150 and 100 BC. It contains at least 37 interlocking bronze gears, some with teeth just 1.2 millimeters wide. It could calculate the position of the sun, the moon, all 5 planets known to the ancients, and even predict solar eclipses years in advance. Scientists used X-ray tomography to read the inscriptions inside. What they found was essentially a user manual for a machine that required knowledge of elliptical orbits, a concept not formally described until Johannes Kepler did it in 1609. That's 1,700 years later. Who taught them this? And why, after the Roman Empire collapsed, did this knowledge completely disappear for over a millennium? If that wasn't surprising enough, let's go to Egypt. 2560 BC, the Great Pyramid of Giza. We've all heard about it, but let's talk about the actual numbers, because they are genuinely absurd. The Great Pyramid is built from an estimated 2.3 million stone blocks. Some weigh as much as 80 tons. The structure covers 13 acres at its base and is level to within just 2.1 centimeters across its entire footprint. The four sides are aligned to true north, south, east, and west with an accuracy of 0.05 degrees. With modern laser-guided surveying equipment, that would be considered exceptional. The ancient Egyptians did it with rope, copper chisels, and human labor. Here's what engineers actually say when they study it. Moving those blocks, even with modern cranes, would be a logistical nightmare. The largest construction vehicles on Earth today struggle with loads of that size. The most accepted theory is that ramps were used, but the ramp required to move an 80-ton block to a height of 139 meters would itself need to be longer than a kilometer, and we have found no evidence of such a ramp. So the question remains, how exactly did they do it? But it gets even stranger. In 1938, a German archaeologist named Wilhelm Knigge was sorting through artifacts in a Baghdad museum when he found something odd. A small clay jar, about 14 centimeters tall, containing a copper cylinder, and inside that cylinder, an iron rod, all sealed with asphalt. It was dated to somewhere between 250 BC and 640 AD. When Knigge filled a replica with grape juice, an acidic liquid, it generated 1.1 volts of electricity. Scientists still argue about this. Some believe it was used for electroplating, coating metal objects with gold or silver using electrolysis. If true, it means ancient Mesopotamians understood electrochemistry over 1,500 years. Before Alessandro Volta invented the modern battery in 1799, others say it was just a scroll storage container. But here's what's interesting. Several gold-plated artifacts from the same era have been examined under electron microscopes. The plating is so thin and so uniform that some researchers believe it could only have been applied electrochemically. We can't prove it. We also can't explain it away. Now let's move to Peru. High in the Andes Mountains, 3,700 meters above sea level, sits a fortress called Sacsayhuamán, built by the Inca Empire in the 15th century. But what makes it extraordinary isn't its age. It's the stones. The walls of Sacsayhuamán are built from massive limestone and andesite blocks, some weighing over 100 tons. The largest single stone is estimated at 361 tons. That is heavier than a fully loaded Boeing 747 aircraft. And these blocks were not quarried locally. The andesite came from a site called Wakoto, over 35 kilometers away. The limestone from Rumakolka -22 kilometers distant. Both locations sit on the other side of river valleys and mountain ridges. But the detail that stops engineers cold is this: the blocks are fitted together without mortar, with tolerances so tight that you cannot slide a piece of paper between them. Some joints contain more than 12 interlocking angles, cut perfectly to match the adjacent block. Ask yourself, how do you move a 361-ton stone across a mountain range? Then fit it with a dozen different angles to match its neighbor. With stone tools, no one has a complete answer. Now let's talk about something smaller, something that fits in your hand, but represents a level of metallurgy we lost. For over 300 years, Damascus Steel, forged in the Middle East from roughly 300 AD to 1750 AD. Blades made from this material were legendary, swords that could cut a falling silk scarf in half, yet hold an edge sharp enough to shave with. They were simultaneously harder and more flexible than any European steel of the era. When modern metallurgists finally analyzed surviving Damascus blades in the 2000s using electron microscopes, they found something extraordinary: carbon nanotubes and cementite nanowires, structures that we only learned to manufacture intentionally in the 20th century. These are nanoscale, atomic-level structures, and ancient Syrian blacksmiths were creating them, apparently without knowing it, through a specific combination of ore, forge temperature, and hammering technique. The exact process died out around 1750. We've spent decades trying to reverse engineer it. We've come close, but scientists still don't fully understand exactly how ancient smiths reliably produced these nanostructures without modern instruments. The knowledge existed, and then it simply vanished. And then there's this: the Nazca Desert in southern Peru, a flat, arid plateau where, between 500 BC and 500 AD, an ancient culture called the Nazca people scraped away the reddish surface layer of gravel to reveal the pale yellow ground. Beneath, what they created can only be fully seen from the air. The Nazca lines cover an area of nearly 450 square kilometers. They include over 800 straight lines, some extending for 50 kilometers without deviation, hundreds of geometric shapes, and 70 animal figures: a hummingbird 96 meters long, a condor with a wingspan of 130 meters, a spider, a monkey, an astronaut-like figure that has fueled decades of speculation. The lines are extraordinarily precise. Using only wooden stakes and rope, the Nazca achieved straightness that rivals modern surveying. One line, when measured by NASA researchers, deviated by less than 0.1 degrees over its entire length, but no one can fully explain the purpose. They weren't roads, they lead nowhere useful. They weren't irrigation channels. The desert gets less than 20 millimeters of rain per year. The most widely accepted theory is that they were ritual pathways for religious ceremonies. But the scale, and the fact that their full form is only visible from hundreds of meters in the air, makes that explanation feel incomplete. Why build something you can only truly see from the sky if you have no way to get there? Here's what all of these have in common: the Antikythera Mechanism, the pyramids, the Baghdad Battery, Sacsayhuamán, Damascus Steel, the Nazca lines. None of them were made by aliens. None of them were made by gods. They were made by human beings, with raw materials, with their hands, and with a depth of knowledge that we are still working to fully understand. And maybe that's the most confronting truth of all. We like to think of history as a straight line, primitive to advanced, ignorant to enlightened. But the evidence scattered across this planet suggests something different. It suggests that human intelligence has always been extraordinary, that civilizations rise, reach heights we don't expect, and sometimes fall, taking their secrets with them. We have mapped the surface of Mars. We have sequenced the human genome. We have split the atom. And yet, we still stand in front of certain ancient walls, certain ancient machines, certain ancient blades, and we say, quietly, we don't know how they did this. The most advanced technology on Earth was once made by hand, by firelight, by people whose names we do not know, and whose methods we are still trying to learn.